We get many questions from young photonics companies trying to scale up production to serve new markets and increase their turnover. And that's where Optica can help, because we have access to leading CEOs and CTOs in over 600 photonic businesses who have the wealth of experience and are willing to share their advice with others. In this series, we explore the business strategies being developed by industry leaders. We discuss the questions that young companies often find difficult to answer. I'm joined at the questioner's table by Michael Hochberg, a well-known Silicon Photonics entrepreneur. We recently sat down with Dr. Anthony Yu. He's currently Vice President of Silicon Photonics Product Management at GlobalFoundries. Prior to being named in this position, Dr. Yu was Vice President at GF's Aerospace and Defense Business Unit. Before joining GF, he held multiple executive positions at IBM, including Vice President of Semiconductor Technology for Engineering and Technology Services. Michael started our interview by summing up the impact Anthony Yu has had on the silicon photonics industry.
Just speaking personally, he's one of the people who has had the most incredible impact on the silicon photonics industry over the last decade. And so it's really a pleasure to have you here.
It's great to be here, Michael and Jose. Terrific we can spend some time together.
So let me start with a personal question.
Sure.
How'd you find your way into photonics?
Well, it wasn't my background by training. It was in 2017 when I was at GlobalFoundries after being acquired by IBM Microelectronics. And the company had the foresight to kind of predict the uptake of data into data centers, mainly driven by mobile traffic. And so at the time, we were looking at the pluggables market, and which was very 3.5 silicon based. And we thought we could apply our silicon manufacturing process control and scale and bring about more economies and greater integration with silicon. So I was handed literally a couple of research papers, Michael and Jose, and said, please go ahead and industrialize this, which literally started from research papers. I thought it would be the grand challenge. So I formed a small team. Michael, you and I interacted. I talked to people like you, and I figured out how we would do this. And so that's how I ended up here today with this amazing opportunity for photonics, driven by not just pluggables, Jose, but now generative AI. So it's kind of being at the right place at the right time, but you had to get started.
I remember the first time I met Anthony. Do you want to tell that story?
You can. You tell it much better.
One of the challenges for many years in silicon photonics was that the people would get excited about it. Executives would get excited about it at big companies. Global was one of the examples of that. And they would get really excited about it, and they would start working on it, and they would eventually do enough work on it that it would get exposed to their leadership team. And the leadership team would look at it and they would say, how many wafers? How many hundreds of wafers? And these are organizations that do millions of wafers a year, right? And then they would disappear, right? Because they would end up doing something else because it just didn't make sense as a business case. It might make sense strategically. And so I joked with Anthony that when he joined, it was lovely meeting him. I wished him the best of luck, and I'd probably never meet him again. And I have to say, I really admire the fact that you stuck with this.
Here we are.
Yeah, here we are.
So why did you? Why did you? I mean, the wafer numbers were not there.
I believed that the company had the ability to combine CMOS processing and MEMS and packaging to bring a unique solution to the industry, which is dominated by smaller niche lines, Jose, such as they do wonderful work. But I thought that if we applied scale properly, we could have an impact. But I probably underestimated the complexity at the time.
It's funny because nowadays you see someone pitching a new idea for integrated photonics, and the question that gets asked is, how does this integrate with silicon?
Yeah.
6-7 years ago, the question when people would pitch something that was integrated optics and silicon, it would be, why are you doing this in silicon?
Yeah.
And it's gone from being a very exotic, very niche thing to being almost the default answer for new projects in some
And I
ways.
think adding to that, Michael, I think for any industry to grow, it needs foundries. And I think that there's tremendous ecosystem of research laboratories and niche 3-5 players. But I think that the scale of foundries is needed for things to grow. And so I've also seen the role of foundries change as well to being a much more collaborative, more partnership-based extension and manufacturing arm of our clients, which has been gratifying to see as well.
So when you say that, are you talking about the difference between sort of process standardization and supporting process differentiation through like a fab light kind of model, like with the
Exactly.
virtual IDMs?
Yes, exactly. And that's been the challenge for us at GlobalFoundries, which is both a challenge and a privilege, which is to be able to take the incredibly innovative stuff from Silicon Photonics fabless companies and find a way to standardize it without confining it. But as Jose has heard me talk at different conferences, to find a way to standardize it so that it can be economically scalable without diminishing the innovativeness of the startups. And that, for me, is probably the most gratifying but maybe challenging part of my job.
You use the word standardize. When I think about it, and this comes back to the rump session last year,
Yeah.
I think of what Global is so good at as being not so much standardizing as modularizing, right?
Yeah.
Like one of the things that I was wowed by the first time I started doing electronics tape outs, which was some years ago, I looked at the menu of process modules that you could get from it was in Global at the time, and I was just like, it really knocked my socks off. There was just this checklist of all of these different modules that you could decide, and some of them you couldn't have. You couldn't have A and B together, but you could have A and C and D and E, and I thought about it, and I couldn't imagine how you managed all of the complexity associated with having 20 or 30 or 50 different process modules that all where you can mix and match them and the statistics work.
Yeah.
And the PDK works as predicted, because if you can't rely on the PDK, it doesn't, you're just not going to get working devices.
Right.
Like that management of this sort of combinatoric complexity is something that I was amazed by on the electronic side, and you've applied it to the optics side.
Right.
As someone who used to spend a lot of my life in the fab, I really couldn't wrap my mind around how you guys did that. Can you talk a little bit about the culture that goes around that?
Well, I probably made a couple of errors. I came from the CMOS world, where from an ASIC standpoint, we would really feature first time right by having completely characterized circuits. Now notice I didn't say modules because that's what we actually had to move toward. And I thought that if you could take these building blocks, like what we had in ASICs, and apply them to photonics, that would quickly allow people to get to market quick, fast, first time right, and capture the market opportunities. What I find is different about photonics that I've come to appreciate is we had to find the right balance between finding modules of active components, give people different ways to do modulation, but have a really high performance detector and have the ability to do beam steering and a low loss waveguide. Some of those things you have to have that, but then you have to allow people the creativity to do different things. And I have to say, since it wasn't my background intrinsically, I had to find that as opposed to dial it in directly. And I think now we have the right balance, but I still want to allow for some creativity, but I have to standardize in some way to make the process manufacturable. Because ultimately you want to have high yield, high throughput, and high predictability of the parts in order for it to realize its potential. That balance is what I think is something that I look for every day.
But the connection with the startups has to be challenging. Many startups come to Optica looking for connection with investors, and investors tell them, is your solution scalable? How you check with GlobalFoundries? And many of these solutions require new materials, sometimes not CMOS compatible manufacturing. So when these people come to you and you have to offer them a very standard PDK suitable to volume production for 99% of your customers,
Yeah.
how do you react? And also, how do you feel when sometimes you see great potential but not suitability to be part of a CMOS line?
Yeah, so the benefit of GlobalFoundries is we have our Silicon Photonics production corridor within our mega fab in Malta, New York. So you take advantage of the fact that, we produce, 500,000 wafers a year, or we will be able to produce that level in there. So you've got the scale and you've got the lithography and deposition tools, but there are unique materials. Now, the selection of what materials to bring in is based on a combination of the best physics, but also, is it safe within the clean room? Is it scalable? And does it come from a reliable supplier? One that we can actually get backup material of. So we've, for example, the Pockels effect is well known within in photonics. There's a variety of materials of which you and I have discussed them, Jose. Things like optical polymers, thin film lithium niobate, which is probably the hot material of the conference, BTO. So I will assess all those for having the right physics properties, but also having one that's got the environmental safety, as well as the ability to be reproducible for the scale that's needed for it. So when I meet with startups and they bring me new material candidates, I listen very carefully and I try to see what's compatible with our facility and our manufacturing site.
And with that, I am actually amazed. As a fan of quantum computing, you were not worried about how suitable the application was to really have the upscale in the market. You believe in the dream and you went for it.
Yes, we brought in what I wouldn't have believed in, but for the single photon detector necessary for quantum computing, we have some unique materials, superconducting light within the fab. Now, I try to hide that from our fab supervisor. I'm kidding, but it requires a lot of careful thought as we implement these new materials in there, but we are, which will allow the industry to grow.
Well, on the subject of startups, like you see a lot of startups.
I do.
And sometimes they walk in the door wanting to convince you to be a customer to them. Sometimes it's as a collaborator. Sometimes it's they want to be a customer to you and they want to design into your process. You can't say yes to all of them.
Right.
What are the things you use to assess? What are the red flags? What are the green flags? What are the things where, you look at them and you go, I don't know. Like what are the big indicators for you that a startup makes sense for you guys to work with?
We have a lot of startups that approach us. Many of them are via our network, which I appreciate. But I look for certain things, and funny enough, Michael, we're very close to many venture capitalists who actually talk to us also about what do I think of this startup, what do I think of these prospects. But the best startups, the ones that are successful, and it's still incredibly courageous to be a startup, period. But the best ones come to us with a clear vision and an intention to use the existing manufacturing process as best they can and get to a minimum viable product quickly. We have some startups that are still dreamy and want to think about the art of the possible. Those are probably best done within a research incubation before they come to us. I'm not able to implement a brand new process, but the smart ones have already studied our PDK and our capabilities, maybe have a different material they want us to assess carefully, but want to get to market quickly because they know what they're building and they know they're unique and have the possibility to bring me volume. That's the other issue for me as at GlobalFoundries is it has to have a certain level of volume for it to be workable for me to be able to support. And we may not be the right foundry for every startup, Michael, but for those that we have under our wings, they're like my children.
Yeah.
I'm very proud of seeing them grow and become unicorns in the industry. It's quite gratifying.
One of the things that I think is a necessary shift in, call it attitude or call it culture among the photonics design community. Historically, the way that a lot of problems have gotten solved is, oh, well, we don't like the plus or minus 10% tolerance on this particular device that comes out of the fab, we're going to go back to the fab and ask them for a 2% tolerance. And sometimes the fab can say yes to that. Sometimes they can say no to that. It's usually an economic question because at the end of the day, it boils down to yield and to R&D and to engineering. But if you're operating in a shared process where there are 100 different users, 20 different users, making these asks is incredibly costly because when you change the process, you don't just make the tweak a sort of unit tweak. It can change the statistics all over the place in unexpected ways. And so one of the things that I've always tried to evangelize is the design teams need to change their attitude and think of their responsibility as figuring out how to solve these uncertainty issues or these variance issues, solve it by design rather than to solve it by changing the process.
Yeah.
And one of the things I really like about what you guys have done is that you've pulled the transistors onto the chip because that gives you a lot of freedom to solve those problems by design instead of by, you know, by yield loss.
Well, the advantage that I think we bring is that we have 300 millimeter tooling. So by virtue of being one of the most advanced fabs, we have process control that gives the designers the very best they can get. But yeah, you're right. They'd come to us and say, we can do better. And we point out what the yield model would restrict that to, and we find a way to properly share that risk.
Right.
It was all about reducing the cost of silicon photonics. Everybody was telling us you need to be cheaper in larger production. And for many years, we were thinking the cost was in packaging and testing, and you brought those as much as possible to wafer level. That was a strategic decision, correct?
Yes, yes. But I will say that as we look at generative AI, it's incredible opportunity. But economics is really factored into it, right? In terms of the cost of computing, both in terms of power efficiency and also how quickly can you monetize data into digital intelligence, and that's quickly being monetized into a dollars per gigabit or dollars per token processed. It's definitely factoring in, and I think it's affecting, Jose, not just the wafer processing, but also packaging and test to the end product.
So what is the next stage? Because now you moved packaging and testing as much as possible to wafer level. The next position is connecting with electronics as much as possible.
Yeah, and also fiber attach is becoming a big, when you look at the packaging challenges for photonics, it extends outside of the chip now in terms of laminate and fiber attach, laser attach. Is it an onboard laser or off-board laser? How does it connect in with the ASIC? And so the cost equation is being spread, but obviously there's a huge investment on my side for the capital required to build these wafers.
How are you thinking about the laser attach thing, both from a technical perspective and from a business model perspective?
Well, we're seeing laser attach itself be very advantageous within the pluggable market, but I think until they address the heat concerns of the proximity of the laser to the very warm ASIC, I think the laser is going to be off chip there. But I think one of the things that's being looked at in the industry is the reliability of that laser in that type of environment overall. And so we're getting, as we talk with our laser partners, they're getting lots of questions about mean time between fail, how many hours can it handle, what's the wavelength stability. So it's definitely part of the overall equation that will predict the uptake of photonics into the AI ML world.
When you think about laser integration, do you see that as something that you guys are going to take responsibility for, or do you see it coming from? Do you see that as being something that the customers are going to contribute? Like, how do you see that getting done?
The business model that exists right now is we have the ability to place lasers within our silicon photonics chip. But very often the customers come to us and say, I want to use this laser from company XYZ, and can you direct me to somebody that can actually place the laser in the cavity, perhaps an OSAT, to do that work? So it's a key feature of the end chip, but it's not one that we're necessarily taking responsibility for. We can prepare the chip for it, but we're not typically doing laser attach at GlobalFoundries.
Got it. What are the things that you think need to change in our industry in order to support it? Like, what are the things you're looking for from other people?
I think, and I mentioned this at one of the conferences that Jose invited me to. I think we're seeing the OSAT ecosystem, the same OSAT ecosystem that brought about the economies of scale in the electronics, start to rise to the photonic packaging challenges, which is different from CMOS, but could benefit from a lot of the cost reduction. So just as we poured a lot of investment into the silicon side of silicon photonics, we're seeing the packaging OSAT ecosystem rise to that challenge with some niche photonic packaging houses coming up, as well as the large electronic packaging houses getting involved. I think ultimately the whole ecosystem of IP and packaging needs to come together and provide a solution at the rate that's being demanded here.
On the semiconductor side, a semiconductor company, when you see the photonics OSATs and you see the active alignment and
Yeah.
the one by one alignment of components, how do you feel? Do you feel this is the way to go, or there must be a way to link more semiconductor-oriented passive alignment processes to the photonics packaging?
Yeah, there's a surprising amount of hand alignment
Yeah.
done as you tour the facilities, and to me, it's very interesting to still see the amount of manual alignment that's used in photonics. But I think the level of automation is happening. You're seeing some unique machines being brought to market by companies that are startups that have a way to automate things like that, fiber alignment, which is going to be super important when you move to the multi-terabit type of connections that we're looking for. But that level of automation is only occurring now because it's still very much of a hand precision type of process.
When you start out with your prototypes, your first 10, your first 20, 50 units, whatever it is, you need the flexibility of something that's not necessarily manual, but that's very human operated. And then you get to the next phase where you're getting to, the hundreds of units, maybe even the thousands of units. And you can go with sort of parallel human automation and do it somewhere where labor is comparatively inexpensive, or you can invest in automation. But the interesting thing is that you invest in the automation and it could take 6, 12 months for the machine to arrive. And if you don't have a good small volume process where you really understand how it works and how it, if you don't have a process that's stable, automation doesn't help you stabilize a process. It just helps you churn through more bad parts, right? It helps you destroy a lot more parts more efficiently. And so one of the things that I've learned again and again is that you often have to do a parallel track where you have an effort to do a manual version to get your early parts out and develop the process. And then in parallel, you have to be developing the automated process.
Yeah.
And from startup land, that's extremely capital intensive, right? And so I think one of the things the industry has to figure out is how do we deal with outsourcing this, right? How do we deal with making it so that the startups don't have to lay out millions of dollars of CapEx?
But at the same time, the hyperscalers, who are the end recipients of all this, the questions that they ask me, as well as everybody else along the supply chain, is, can you scale this?
Yeah.
Right.
So it's kind of a chicken and egg.
It is,
but ultimately it needs to drive automation.
Yeah, I'm sure it does. And in the electronics industry, like one of the amazing things is you even in places like Silicon Valley, which are relatively expensive to operate, there are test floors with hundreds or thousands of test machines and of packaging machines and all the rest. And you can go and rent them for hours or days, short periods of time for the electronic stuff and get a big batch done.
Yeah.
And that kind of sort of outsourced test floor or outsourced packaging floor where, you need to do 10,000 units, no problem. Send it to us, we'll get it back to you in a few days. Like that doesn't exist in the optics industry yet.
Not yet. Yeah.
Maybe someday, maybe another 10 years, right?
Hope so.
Yeah. What other kinds of questions do you get from the hyperscalers?
Yeah.
That's an interesting
Scalability is a key thing. How stable is the technology? Because as you know, the rate of compute is so fast.
Yeah.
So fast now. As we bring in new materials and new techniques, how reproducible is it? You can show something once, but can you build millions of units? So we get a lot of those types of questions. They're kind of they have to ask these rigorous questions because at the end of the day, reliability is really key to them. So they don't want any downtime in the data center. So reliability is an important question that we get asked about a lot.
But what's interesting is they're usually not asking you about something you've designed.
No, they're asking about the feasibility of the end product.
Right.
Like how stable is the manufacturing process? How many have we built? Do we understand who the OSAT is that's building it? So it's forward-looking questions because, as you know, this is still a very young industry. But I think they're excited by it, but they're also cautious.
There are questions that you cannot easily answer yourself. So do you have to sometimes cooperate with others or sit down at the round table and say, let's answer that question from the hyperscale?
Very much so. A lot of times we'll have the end user come to our fab to talk about the product, but I'll have our partners in the supply chain in the same conference room with us. So collectively, we're all there at their mercy.
I mean, it's super interesting because like you've got the hyperscalers, you've got the OSATs, you've got the contract manufacturers, you've got the foundries, and then oftentimes you have the organization that's actually doing the design, which might be a startup company or a smaller organization, and it's this very complicated multi-party interaction.
Right.
What's the model? Like if you're talking to a startup team or a group of startup founders, like they have a broad choice of different kinds of business models, right? They could buy wafers from you, they could take it to the OSAT, and then they could try to sell it as their branded part. There's 15 other variants of it. From your perspective, what do you see as the successful business model for fabless startups that are coming to you to build stuff? Like, what's the business model that makes sense?
It's too early. There is not, I wouldn't be able to say there's one particular model. There are some fabless companies that want to go all the way and have an end product of their own that brings them fame, fortune, and hopefully a successful IPO. There are other people who want to enable the industry through a chip and use contract manufacturers and their values in the chip itself. So I wouldn't say there's any one model that I've seen right now, but ultimately the capability of the chip to handle high bandwidth and low power is what people are looking for overall, whether it's for a unique device or whether it's for a chipset.
What about the IP ecosystem and the software ecosystem?
We're not as involved in that. Obviously, I know what they're doing from a product standpoint, but that isn't something that directly impacts me as a foundry.
That's interesting because like you look at TSMC and on the electronics side, and in some ways their big network effect is that there's billions and billions of dollars that get spent every year building IP blocks, right? And I sort of think of a lot of what you're doing, like laser stuff or the new materials for modulators. I see those as IP blocks that you're dropping into your process. Do you see a growth coming in the Silicon Photonics sort of fabless IP ecosystem?
I think so, but amazingly enough, right now, I've personally tried to get people to contribute IP toward an IP ecosystem that would allow other people to use it because it's already been proven in a product, and I think the industry would grow faster that way. But right now, a lot of the design work done by our customers, big and small customers also, very proprietary, a reluctance to share. Now, there are other people that are basically design services companies that will do it and put the IP out there in the open. Right now, even within the ground rules that we have, a lot of the devices and circuits that are being practiced in photonics are being deemed proprietary and not ready to be shared. I think that's going to change. That's going to change over time.
It's funny because like oftentimes the things that are highly proprietary that people are most protective of, and I've been guilty of this myself, they're actually very duplicative. There's actually 10 places that are doing these very proprietary things that are all very similar.
Obviously, I treat every foundry customer separately.
Yeah.
And I guard confidentiality between them. I have to do that as a foundry. But if they say it's valuable, we'll protect it. And we'll make sure that IP doesn't get duplicated by somebody else.
We think about other applications because most of the time we are talking about datacom, telecom, transceivers. Is there any new application that is making you very excited? And I know quantum is one of them, but are there others that are making you very excited?
Yeah, Jose, as I said, when I was reading the research papers in the very first days of my time at GlobalFoundries, we had to pick an area where we wanted to concentrate on process development and IP support. So as I mentioned, we focused on the data center, both for the pluggables, the top of the rack switches at the time, and still very datacom, a little bit of telecom focused. And so that's the root of what we're doing at GlobalFoundries, with a little extension of that process with some new materials for quantum computing. But I think photonics is going to be, once we get to the scale driven by what we're doing in datacom, we'll see it in automotive, FMCW, we'll see it in sensors, we'll see it in medical devices. There's some very interesting work being done for at-home COVID testing. Anything that can change the refractive index of light has a wonderful application, and there's some very powerful things being done for at-home medical sensors. Those are areas that I'm not concentrating on right now, but I think once we get the photonics base established, there's a lot of different ancillary markets. I mean, you'll see, light has the advantage of being very, very fast and very little loss across great distances. And I think we'll see photonics become more pervasive.
In the interview, you talked to us about your passion for combining MEMS with semicon. Free space optical communication is coming really strong.
It is, especially to third world countries. There's some amazing work being done in free space communications.
And we need to bring internet to every part of the world. And for that, we need this way of transmitting waves in the air.
We are actually very quietly with a couple of companies looking at that. I think that's important work. Sometimes we have to do things more than just what we want to just make money on. We need to do things for the good of society. So we found a way to support that.
But integrating RF and silicon photonics is one of the next milestones.
Yes.
And there, do you have already some groundwork to bring more MEMS and silicon photonics together?
We do, but we have to be careful. We have to make sure that we do what we're good at. And MEMS isn't in our heritage, but you can't do fiber attach without doing some of MEMS type processing. And so it is part of our process now, which is unique from the rest of the stuff we do at GlobalFoundries.
So let me ask you one more question. I know that OFC is an incredibly busy time, and I'm grateful that you've taken so much time.
It's a pleasure. It's great to be with you guys.
So what's something that you've developed over the last few years that's an unorthodox view? Something where you see it surprising the broader industry because people just aren't taking it into account yet?
That's a really good question. I think we're going to surprise people with photons as qubits. I think the number of useful qubits will be greatly enhanced through photonics. So I think that's one area where I think we'll surprise some people. And I think we'll shock people as we bring in these new materials, with how quickly the rate of compute can increase. I mean, the rate of compute is changing every 3.5 months, I read. And so for things to catch up with that, you're moving beyond Moore's law now. And now the rate of computing isn't driven by simply lithography on GPUs. It's a question of how can you use optical interconnect to make the bandwidth grow at unheard of speeds. So I think we'll shock the world with that.
That's amazing. The excitement around new materials from someone who's sitting on top of one of the big CMOS fabs, like that's an amazing development.
We'll have to make sure that I don't shut down the fab with the
But yeah, I mean that's a sign of success for the field.
It is.
All right. Thank you very much.
Thank you, Mike.